Hey, today I'm with Marcin and Alex to talk about DQX. But first, let's get to know more those two awesome guys.
Hi everyone. My name is Marcin Wojtyczka, and I'm Senior Resident Solutions Architect at Databricks, so part of professional services. We basically deliver projects for customers, and I'm also working on Databricks toolings, and I'm the co-author and tech lead of the DQX project.
Hello everyone, I'm Alex Holt. I'm a lead specialist solution architect at Databricks. Like Marcin, I'm working with customers, but more before the professional services is involved. Beside my day-to-day work, I'm closely working on things like Terraform provider and many of the Databricks Labs projects.
And for those who are watching this session, just fun fact about Alex out. I remember when I joined the company, whenever I was looking on before ChatGPT, whenever I was looking for an issue about Spark, I go to Stack Overflow, and every time there was Alex who was responding to those questions. So let's now just talk quickly, or like the topic of this session, DQX. Can you tell us more about this framework and what was the, let's say, the objective behind building this open source framework?
Yeah, I think I can start. So DQX is a data quality check and enforcement framework that was built based on the real world experience working with our customers. So the history of project started almost 4 years ago when we started to get more requests about getting the clear data for machine learning and other projects, so that people don't spend too much time on the data engineering outside of the responsibilities. And we've identified a number of inefficiencies in the existing open source frameworks like DQ and great expectations, especially for the streaming workloads. And we started to build slowly the functionality. And then as we get it adopted by the more customers, it was expanded and for the things like even if you have the built-in functionality like Delta Life tables expectations there, we still had some gaps with the GKX is filling in. One of the, besides the data quality enforcement and like quarantine, the bad data, detailed reporting, etc., one of the objectives was like to make the data quality very easy to implement on the existing Spark workload, so especially for the streaming. And for example, this linked to the creation of the components like profiler that simplifies the creation of the data quality rules, because it's very tedious work to add some more data quality rules if you write them manually, but it's much more easy when you get a profiler, you identify what could be the unique values, what you have any missing data or outlier, and then you just review the proposed data quality rules candidates and accept them and put into your pipeline. And then we are product analyzing it by saving the text in the files, in the delta tables, etc. So you can reuse between the multiple pipelines. You can organize libraries of the data quality checks that you can apply across some multiple. And really, we worked on some customers when we had hundreds and thousands of the pipelines applying the similar data quality rules, but also having some unique data quality enforcement for specific pipelines.
And what's the difference with the Lakehouse monitoring? Because I know it is also a way to be able to track the quality of a model, of table. Is it something that will you to, like, in addition to Lakehouse monitoring, or is they say a competitor, or like what's the difference between those two frameworks?
Lakehouse, so DQX complements Lakehouse monitoring feed. So we really closely work with Lakehouse monitoring product team to incorporate necessary functionalities that we observing by the in the customer requirements and having the things that are still maybe not implemented in Lakehouse monitoring uh, for things like streaming workloads there, because Lakehouse monitoring at some degree is working with a whole data set. It allows to implement some data quality checks that are such as anomaly detection, there that are impossible to already have to do with streaming workloads. But really, we are closely working to incorporate as much of the DQX functionality into the Lakehouse monitoring and corresponding products like Delta Life tables. So we are in close contact with them. So eventually we are hoping to get everything be a part of the product.
And so far, like do the DQX support Python, SQL, Scala? What are like the languages that you currently support with DQX?
So primary usage of DQX right now is Python. So also like we had the implementation for Scala as well. It's not published. We are concentrating on Python. Some of the components, like profiler, can generate the SQL expectations as well. So you can profile your data set, generate a data quality rules candidates, and then you can plug in, like just copy paste the generated code into your DLT SQL pipeline or streaming table, something like that, and you get at least you speed up the things. Python on other side a bit more flexible when we talk about like metaprogramming or automatic generation of the code. It's there loading the libraries of expectations from the Delta tables or files. So it's simply not possible to do with the SQL, but they can easily complement, and we have seen the people applying the DTX to SQL as well.
Yeah, that being said, we do have actually like we do support like SQL expressions. That means you can actually do the checks using SQL, but the execution has to be from Python, basically. So we support Python and kind of SQL, but the execution has to be from Python. But you can certainly do like SQL-based checks. So we do support like SQL expressions.
And what are the requirements that I need to run the DQX? For example, if I install this, like let's suppose I have Spark on premise, I have like everything installed. Like I can install DQX and get started, or I need to have a Databricks account to use it.
Yeah, you actually do need to have Databricks accounts. Of all basically Databricks Labs projects require basically it's a Databricks license. We have Databricks license. That means in production we do require the QX to be run on Databricks. The installation process itself is super simple, and I will also demo this. You just need to pip install it, so on package. There is also another way to install it, let's say more as a tool in the workspace. So using Databricks CLI, you can also install the QX. And yeah, the simplest, basically you just need Python installed on in your environment and just pip install it, and that's pretty much it.
Okay, and I think for folks who are gonna be watching this recording, keep in mind that DQX is a Databricks lab, which means if you're running some issues, do not open a ticket. Just go to GitHub and raise an issue, or you can talk with Alex, Marcin, and all the different contributors to this project. And I think you have a demo for us that you can show like how you can get started quickly with the DQX?
Yeah, let's do that. Let me share my screen. I won't show everything, but I would say the most important things just to get started with the QX. I hope you can see my screen now.
Yeah.
All right. So here I am in Databricks workspace, and the only thing, and this is basically a Databricks notebook. To install the QX, I just need to pip install the QX library. That's all I have to do actually inside the workspace, and then I just restart the Python environment, and then I can work with the QX. I can also use it basically wherever I am in the Databricks workspace. I can use it. So it could be also a drop. It doesn't have to be a notebook. So let's start with profiling. So basically, whenever you have a data set, you probably want to get an idea what is the profile of the data, and based on that, we can generate a quality rule candidates. So this will be, so we'll look at the data and profile the data and then generate quality candidates. And those candidates then you can, use directly in your application, or you can adjust as needed. So in this example, I'm just creating a simple data frame in Spark. So nothing fancy. I create a workspace client and initiate this DQ profiler object. And using that object, I profile the input data frame, and that gives me some summary statistics and profile. This is probably not something you will necessarily need, like probably need to use, but it's there if you need. Basically, it gives you some statistics over the data, basically just profiling statistics. And based on that statistics, then using this DQ generator, we can generate the rules candidates. So based on this data I had, very simple here, it identified that column 1 should be not null, and if it is not null, then we should say this is an error, it shouldn't happen. And column 1 should also be between 1 and 2. This is basically what we see based on this simple data frame, and so on, right? So it will give me the initial set of rules I can use directly in my application to do quality checking.
Just to understand, the goal is to use a clean data or a sample of like what the data should look like, and then use this profiler, and this will generate the all the rules that I should have.
Exactly. This gives you basically candidates that you can use. You don't have to, but it probably give you a good set of initial rules you can include. It will give you a better idea of, what is the data that you have, and give you this initial set of rules, checks that you can use. So these checks we can then save in the workspace, basically with this method, and then we can use it in the application. What I want to also show here, this is what Alex mentioned, we can also generate DLT expectations. So in SQL, Python, or Python dig. So we can just take those and use with DLT directly. So basically just take these and use this in the DLT pipeline. And that also can save you quite a lot of time, when you have no idea how, what is the profile of your input data. So that's kind of the what typically user would start with as a first step: profile the data, generate the candidates, and then they can apply it. So here again, I have another data frame, very simple, just to showcase this functionality. I create this DQ engine. I load the checks that I had previously, generated, and I probably have to run it from top to bottom. Just do that again. There are some imports I haven't included. All right, so now we can see that once I load the checks, I can then apply those by metadata and split. That means I will get the good data frame and the bad data frame. In this case, I name it quarantine. So the good data frame contains all the records that have no issues. So we'll just have, the records that have no issues, and the quarantine data frame or bad data frame will contain records that have issues. In this case, column 3 is null and it should be not null. And this is reported as additional column in the data frame. So very simple, we take the original data frame, we apply the rules, and we report it back with additional columns. And we can either split it into 2 data frames, good and bad, or valid and quarantine, or put it in the same data frame. That's another option. In this case, all the original data will be there, plus the reporting columns. So we won't be splitting. This is just to run over the data that you have and generate and quality and apply quality checks. So this is the simplest way of using DQX. What we can also do, then if we manually create those checks, define those checks, we can also validate if they are correct. So typically the user will profile the data, would generate the quality rules, and probably also make some manual adjustments, maybe, update the rules or add more checks. And after that, the user can also validate those. In this case, we validate the checks. And if there is any issue in the configuration, we can report that back. And that would be typically run, from a CI/CD process during deployment. So when we deploy the application, we deploy the checks. We also validate that they are correct before we use them. Now, there is also a way to define checks in the code directly, either as a YAML file or as DQ classes. So let's start with the YAML definition. It's basically the same what you've seen in the generated by the profiler and generator, but we can also define it manually here. So I have a few rules here. I expect column 1 and column 2 be not null. I also expect column 3 to be not null and not empty. I expect column 4 to also be not null and not empty, but only for column where column 1 is less than 3. So this is also something we can do. We can filter, so apply the rules for specific, specific rows or specific part of the data, the input data. And this is basically a SQL expression here. And so on. We have about 25 rules at the moment, and as we are getting feedback, we are implementing more of this. So expect, to see more of this. And these are also documented, in our documentation. And how we use it is exactly the same. I have some input data frame, and I can, of course, load it from a table, or I can load it from a path. Then I apply the checks. So I define those checks here. Then I upload apply those on this input data frame, and I get 2 data frames back, or 1 data frame back, depending on the method I use. And then here we see the results, right? So we have some errors and warnings, and there is basically distinction between errors and warnings. So when you define criticality as warning, it means it's just a warning. That means we will include this record in the good data frame, and when it's error, we will only include it in the quarantine data frame. So this is how you can basically mark certain issues as just informational, and some as important, and that should never be put to the output. In this case, we have 2 issues, for one row, column 2, and it's, is null, and column 1 is not in the allowed list. So it should be 1 or 2, and it has some different value. And then we can also define the rules as DQX classes. So very simple. We define this DQ rule check. We provided a name, which is optional. You can also skip it. We provide criticality and what kind of checks and for what column you want to make it. And this is basically the same that you've seen in the YAML definition, just as code. And it's really a user preference which method to use. And how we apply the checks is exactly the same. Just use the apply checks and split, or apply checks. And then again, you get this data frames back. Here just a little bit bigger, example with more checks. So how you would typically apply these checks in the Lakehouse, medallion architecture. I would say majority of cases would be to do it between bronze and silver. So as you are processing bronze, you would like to make sure that the quality is correct, and you don't want this bad data to be persisted in silver. So you typically do it there. So this is just an example. And here we are using New York taxi data set. And we are using, we are checking non-null, also some, values. And here is an example of SQL expression, for example, where we compare 2 columns. So pickup date time should be greater than drop-off time, as an example. And this is an expression, so I can put any SQL kind of expression here. And so when we read the data, this is like let's imagine this is like a bronze data from the bronze layer. We apply some transformations. We do the quality checks as before. And this is the good data frame, basically the silver data. And this is the quarantine data set. And we see there are actually quite a lot of issues found in this data set as per our checks. And then we can write, this will be our silver data set that we can write out. And quarantine is probably something we would persist in a different place and investigate the issues before, we can curate maybe this data and re-ingest the silver. All right, so just one more thing I want to cover here is to defining your own checks. This is quite powerful in DQX, so you can define custom checks. So I mentioned we have like a lot of rules, standard rules already implemented in DQX, but if there is something missing, first of all, we would encourage you to create a pull request to add those, so that more people can benefit. But if this is a rule just for you, like a special you need some special conditions, you can define your own checks, and you just have to make sure that you return this main condition, and you can implement your own logic. In this case, we check if the column ends with full. We don't have this check, in the QX, so you can implement it yourself. And then we can apply this directly. So you can see here, we use check ends with full. Ends with full is basically our custom check that we defined here. And then we can apply it the same way as before. Apply checks, and we'll have a custom rule implemented. And here another example of SQL expression. So you have the choice of either creating this reusable function, the check, or you can create a SQL expression. Of course, with SQL expression, it's probably something that you have to, if this is something that you want to reuse, you have to kind of copy and paste, while this function you can reuse. But these two options exist, and it's quite powerful. Last but not least, really just the last thing here I want to cover today is that you can define you can customize certain things. For example, you can customize the columns, right? That you want to report the issues in. So it doesn't have to be just underscore errors. You can actually define your own things there. And if you want to know more, we have. If you go to GitHub page, you'll find a link to the documentation, and you have like a user guide which explains pretty well how the DQX works, and you can just follow along. We also have demos. The one I've just showed is available here as well, so you can download it. You can basically just import it in the notebook, in the Databricks as a notebook directly, and try it out.
All those links will be in the description of this recording. I think it's super useful, and I'm already starting thinking about like the next step will be maybe to have like a dashboard, like thinking of all those metrics and records can be stored in a table and then display them over a dashboard. Can even like put maybe some alerts, like in case we have an outlier or something, and then alert to webhook or whatever you can think about.
It could be built. It's really one of the powerful things of the DQX, that you get a very detailed information about which text failed and why it's failed. So basically, what kind of because I had a customer with a similar framework. They built themselves, and when you have a table with 2,000 columns and you have 10,000 data quality rules applied to this table, you need to understand what really failed, because it's not simply just is now of this specific column or something like, but it could be very complex business rules, especially like when you have rules that covering multiple columns. And then we can have a really can build a dashboard, say like how many rules failed, why, on which day or which word, for example. I worked with one car manufacturer in Germany, for example. We built the dashboard where each owner of the pipeline on specific factory inside the company can go look into the how much data, because it was really very different in the data quality between the different factories. But the most important that it was not simply just, okay, we have clean data or something like. It was possible to identify the machines that were misconfigured. So basically, the people we can track that, okay, for example, the date and time is set incorrectly on this specific machines. It's reporting this. And then we can say, okay, somebody needs to go and fix the settings of this machine, for example, because it's not only the data impact, it will be also the impact of the parts that are produced by this machine, for example. And this was really possible to do with DQX functionality.
Just maybe to add to this as well, we do have actually like a simple dashboard. This is something we just started a few weeks back. If you install DQX in the workspace via Databricks CLI, so basically just Databricks Labs install DQX, it will install like a profiler job, it will install dashboard. This is a very simple dashboard at the moment, but this is probably a good starting point if you want to build something more sophisticated. You can use that as a starting point as well, and we'll be, extending the dashboard certainly in the next releases.
That would be amazing, right? I mean, I'm super excited by this framework, and it just shares with as many customers as possible, and so they can give it a try. Because, like, I've seen a lot of people like having a lot of data, but they keep struggling with the quality, and sometimes some other framework are not good enough, and they start doing this DIY. And the goal is, rather than implementing something that already has been done, why reinvent the wheel? Just use something like such as your framework, and they can like gain a lot of time and focus on what bringing the value, rather than just doing some tasks to clean the data and make sure that it's good and ready to be used. Thank you.
I think
so much.
Go
ahead.
I think also where the DQX probably stands out is simplicity. If you take, the other frameworks, Alex mentioned a few, you really build like another project, and sometimes it's bigger than the actual business logic, and it becomes really, really big and huge. So we focus really on simplicity, making it really easy for users to use. And whatever functionality we are adding, we try to keep it as simple as possible, because we know from other projects this can quickly become very, very complex.
And on the same topic as well, so one of the goals of DQX was to enable non-engineers to apply the data quality to their data. And really, it's always a bit of not a trade-off, but similar things like data owners. Very often they're business people, but they know the data domain much better than the developers. And as we need to have the developers working closely with these people, but all sites could be very busy there, or we can give something like a self-service, and then the people can easily add the data quality to the pipelines. And what we have seen very often is a lot of functionality in DQX field that we can integrate it with what I call metadata-driven pipelines, when you have like standardized pipelines, but maybe the data quality rules could be slightly different. They give this framework to people who are not engineers, but they can quickly customize and start to get the clean data for downstream consumption.
All right, that's perfect. Anything else to add, Marcin?
No, I just encourage people to try it out. I think it's it's, as you've seen, it's very simple to install. Just try it out, import. I would probably start with one of the demos, get a feeling of the tool. And if you have any feedback, we would love if you, report any new ideas or any, feedback in GitHub. We have discussions and we have issues. I think it's a good way to interact, and happy to to see more people using the QX.
Correct.
Thank you.
Thank you so much, Martin. Thank you, Alex. And maybe see you for the next release.
Yeah, thank you, Yusuf, for having us.
Thank you.